Hello and welcome to this demonstration of CipherTrust Transparent Encryption. CipherTrust Transparent Encryption, or CTE, is the file encryption and access control module of the CipherTrust data security platform. In this demo, we're going to secure data that was discovered using the data discovery and classification module and protect it using an extra layer of encryption and access control to prevent privileged access. To start with, we need an encryption key. In this example, you can see we have an AES-256 key called LDT Quarterly. This key is maintained by the CipherTrust Manager platform and rotated on a regular schedule. Next, let's take a look at the elements that make up a CTE policy. CTE policies are made of reusable components. You can see here there are 4 different types. Resource sets, which allow us to specify specific data types. User sets, which combine users and groups. Process sets, which allow us to specify specific programs or tools. And for high security environments, signature sets, which allow us to specify specific files based on their signature. In this example today, we're going to be using user sets and process sets. In this example, there are 3 levels of access we wish to provide. Authorized users will be able to open the file normally. The additional encryption and access control will be completely transparent to them. No-key users will be able to copy or open a file, but will not be able to decrypt it. This is useful in cases where an administrator may need to move files around, or you have batch processes that transport files between servers, but you do not wish them to be able to see the data. And then finally, we have blocked users. Blocked users, obviously, will not have access to the data. If we take a closer look at the authorized users user set, we can see it contains 2 entries. There's a user called AllData, and we also have a group name called CTE Authorized Users that is a member of our Talus demo domain. This is coming from Active Directory. If we look at our blocked users, we can see there's a username called NoData. And then for our no-key users, we can see there's a user called NoKey. We'll be using these users during the demo to show the access levels. Next, let's take a look at the CTE policy. In this demonstration, we're going to use a live data transformation policy. Live data transformation, or LDT, allows online rekeying of the data while it's in use. This means that the systems do not have to be taken offline in order to apply a new encryption key. Now let's take a look at the structure of the policy. The policy is made of 2 components, security rules and key rules. Key rules are very straightforward. It's simply the encryption key that we wish to use to encrypt the files. Security rules are similar to firewall rules. They're read from top to bottom, and the first rule that applies is what grants access or denies access. In this example, you can see that the user set blocked users for all operations is denied, and we're going to audit that the attempt was made. Authorized users, however, for all operations are permitted, and we're going to apply the encryption key on their behalf. It's important to note that the users do not have direct access to the key. The encryption key is applied for encryption or decryption by the CTE agent. We also have the no-key users who for only read access are permitted, and we're going to audit that access. If they try to write or modify any of the files, they'll be denied. And then finally, we have a catch-all that says no matter the users, no matter the program, for all operations, deny and then audit that access. The CTE policy is applied to a client via a guard point. If we look at the registered agents, we can see we have this Windows server. And going into the Windows server, we can see that we have an active guard point already. It shows us that the file demo LDT policy has been applied to this particular path. In this example, we're going to create a new guard point to protect some sensitive data that was discovered with data discovery and classification, the DDC module. In this case, we're going to say create guard point. We can select our policy. So we're going to select our file demo LDT. We're going to tell it what path we want to protect. We can type it in, or in this case, I'm simply going to browse. And we see that there's a folder called sensitive information, sensitive data. We're going to protect that, hit create. Allows us to choose if we want to reuse these settings on another guard point. We're going to say no. At this point, the agent's going to be updated with the new guard point information. It's going to establish that guard point on the folder. And then once that guard point is established, the data is going to be encrypted using LDT. Now that the guard point has been established, we can see that the data is being rekeyed while the services are online. Now let's test the policy to make sure that the access control is being applied. In this example, I've logged into the server as administrator. If I try and go to the sensitive data folder where we applied our guard point, you can see that I get access denied because I don't match any of the security rules within the policy. This applies even to the built-in system account, which means we can protect the data from the operating system. In a compromise scenario where an account is compromised and then the user context is escalating to the system account, this can be helpful in protecting sensitive data. In this example, I have a program set up to run WordPad as the NT Authority system user. Notice that in this case, I still can't open that data because I don't match the security policy rules. Next, I'm going to attempt to open the data using the AllData user. This user is a member of a user set that, based on the policy, should have access to the data. If I browse to the sensitive data folder and open it, I can see all the data. And if I go to read the data, I can see all of the sensitive data in clear text. Note that there's no indication that there's additional encryption and access control being applied to the file. Next, I'm going to attempt to open the data as the no key user. Based on the policy, I should be able to access the file, however, the agent will not decrypt it on my behalf. Browsing to the sensitive data folder, again I can see a list of the files that exist, but when I go to open it, notice I only get ciphertext. From a practical standpoint, again, this is mainly useful for things like batch processes, where you may transfer a file from a drop zone in a DMZ to a secure network on the internal network, and you don't want your batch processes to have access to the data that is transferring. Finally, I'm going to access the data as the no data user. Similar to the privileged account, we'd expect that we should not be able to access a secure folder. And we get an access denied, which is exactly what we expect. CTE produces a robust set of log information that can be forwarded via syslog to your SIEM solution or other log analytics platform. In this example, we can see a dashboard built in Splunk Enterprise, representing a timeline of activity within CTE guard points, trends related to users and processes. We can also go into the details to specifically look at any individual user, process, or file and determine why they were permitted or denied access. For example, if I click on this link, we can see that CTE is providing an effect code. This shows us every security rule within the policy and why a user matched or did not match for access. Here, for example, we can see the first rule did not match based on the activity. The second, third, and fourth rules did not match on user, and then it matched on the fifth rule. With these effect codes, we can determine whether access was granted or denied, and specifically why it was granted or denied. This also allows you to determine whether encrypted data was sent in the clear or was still protected as ciphertext.